What if you fell into a black hole? This isn't just a sci-fi fantasy. It's a journey into the most extreme physics in the universe. So, buckle up, because we're about to take a one-way trip into the abyss. First things first, what even is a black hole? Imagine a star, way more massive than our sun, running out of fuel. It collapses under its own immense gravity, squeezing all its mass into an incredibly tiny point called a singularity. This creates a gravitational field so powerful that nothing, not even light, can escape once it crosses a certain boundary. This boundary is called the event horizon. It's the point of no return. So, let's say your spaceship has a catastrophic failure, and you find yourself drifting towards a black hole. What happens next depends on the size of the black hole. You might think a smaller stellar mass black hole would be less dangerous. You'd be wrong. It's actually far, far worse. As you'd approach a smaller black hole, you'd experience something scientists call sphegettification. It's a fun word for a truly gruesome process. The black hole's gravity is so intense that the pull on your feet would be astronomically stronger than the pull on your head. This difference in gravitational force, known as tidal forces, would stretch your body like a piece of spaghetti. You'd be elongated, thinner and thinner, until you're literally torn apart, atom by atom. Your body would become a stream of particles, spiraling into the black hole. Not a pleasant way to go. You'd be ripped to shreds long before you even reach the event horizon. Now, let's consider a much more hospitable destination, a supermassive black hole. These are the giants that lurk at the center of galaxies, including our own Milky Way. They can be millions or even billions of times more massive than our sun. Because they are so enormous, their event horizons are much farther away from the central singularity. This means the gravitational curve is gentler. The difference in the gravitational pull between your head and your feet would be negligible as you cross the event horizon. So, you could actually cross the point of no return completely intact. From your perspective, as you pass the event horizon, you might not even notice anything dramatic. No bells, no whistles, just a one-way ticket into darkness. But for an outside observer, say your friend watching safely from a distance, your fate would look very different. This is where Einstein's theory of relativity kicks in, and things get really weird. As you get closer to the black hole, its immense gravity starts to warp space-time itself. To your friend, it would look like time is slowing down for you. You'd appear to move in slow motion, getting redder and dimmer as the light from your body gets stretched and loses energy. This is called gravitational redshift. You would seem to freeze at the edge of the event horizon, fading over an infinite amount of time, never quite crossing it from their point of view. They would never see you disappear. You'd just become a permanent, frozen image on the brink of oblivion. But back to you. You've crossed the event horizon, alive and well. What now? Well, the good news is, you're in one piece. The bad news, your fate is sealed. Inside the event horizon, the roles of space and time are flipped. The direction forward in space towards the singularity becomes forward in time. Just as we can only move forward in time in our everyday lives, inside a black hole, you can only move towards the singularity. There's no turning back, no fighting it. Every possible path, every direction you could try to move, inevitably leads to the center. As you continue your journey inward, the universe outside would appear to speed up from your perspective. You could theoretically watch billions of years of cosmic history flash before your eyes in a matter of moments. You'd see galaxies form and die, stars ignite and fade. You'd witness the entire future of the universe in a final, spectacular light show, all condensed into your last few seconds. All this time, the tidal forces are getting stronger. Even in the supermassive black hole, sphegettification is inevitable. It just happens inside the event horizon instead of outside. The immense gravity would eventually stretch and tear you apart, just as with the smaller black hole. The only difference is that you got to experience the mystery of crossing the event horizon first. And then what? You, or what's left of you, will finally reach the singularity. This is the central point where all the mass of the black hole is crushed into an infinitely small, infinitely dense point. Our current laws of physics, both general relativity and quantum mechanics, break down here. We simply don't have the scientific language to describe what the singularity is or what happens there. Is it a gateway to another universe? Is it the end of existence itself? We just don't know. Your journey ends in a complete and total mystery. There's also another wild idea called the firewall paradox. Some physicists theorize that the event horizon isn't a calm, quiet boundary at all. Instead, it could be a chaotic, high-energy wall of fire that would instantly incinerate anything that tries to cross it. So, instead of a gentle float into darkness, you'd be vaporized the moment you touch the edge. It's a debate that's still raging in the world of theoretical physics. So, to recap, falling into a small black hole means instant sphegettification. Falling into a supermassive one gives you a brief, surreal journey where you witness the future of the cosmos before, while also being spaghettified, and then crushed into an infinitely dense point that defies all known physics. Either way, it's not exactly a dream vacation. But it's a fascinating thought experiment that pushes the boundaries of our understanding of space, time, and the very fabric of reality. The universe is full of incredible and terrifying wonders, and black holes might just be the most extreme of them all. So maybe it's best we continue to study them from a very, very safe distance. Thanks for joining me on this mind-bending journey. If you enjoyed this trip into the abyss, make sure to hit that like button and subscribe for more cosmic adventures. Let me know in the comments what other what-if scenarios you'd like us to explore. Until next time, stay curious.